Hello, my name is Chris Willman. I'd like to welcome you to our presentation. Today, we're going to spend a few minutes to make everyone just a little bit more comfortable with some of the fundamentals of zero trust architecture. Just to give everyone a brief lay of the land, I'm going to briefly introduce myself. Then I'm going to describe zero trust and some of the fundamental concepts associated with it. I'm going to talk about who is migrating to a zero trust architecture and what is driving some of those organizations. Finally, I'm going to discuss how to implement a zero trust architecture, how to develop a plan that has the best chance of success, and enumerate some lessons learned from organizations at the beginning stages of zero trust architecture migration. If you have any questions during the course of this presentation, please submit them through the chat window, most likely on the right-hand side of your screen. There will be a Q&A session later today where they will be addressed. So who am I and why am I speaking with you about zero trust? My name is Chris Willman, and I'm a longtime IT and cybersecurity professional. I'm currently a doctoral candidate with my dissertation involving the development of a zero trust architecture implementation and assessment framework. In my day job, I'm a principal cybersecurity engineer working for a federally funded research and development center where I develop zero trust related implementation guidance for large organizations. Additionally, I'm a member of the IEEE Zero Trust Security Working Group and a Cloud Security Alliance Training Expert Group and CSA Research Group member. In IEEE, our group is tasked with the development of a Zero Trust Architecture implementation standard to be used by the international community. Regarding CSA, I'm involved with researching specific technical topics to support the development of Zero Trust training material. Finally, I spent the last 10 plus years developing and training cybersecurity assessment teams using various standards and frameworks. I can honestly say I love what I do. I'm looking forward to sharing with everyone today. What is zero trust? For those of us that have been in this industry for any length of time, I think we're all used to the idea of the new shiny penny or the next big thing. When we actually get down to the details, most of these big things are really just repackaging of tried and true ideas. As I continue speaking today, I expect zero trust will likely be recognized as a similar phenomenon. One important distinction is to realize the difference between zero trust and zero trust architecture. The definitions you see on the slide here are both from the National Institute of Standards and Technology, or NIST, Special Publication, or SP 800-207. Those of you that may be unaware, NIST is the organization whose mission it is to create many of the technical standards used by the US federal agencies, and this particular document specifically describes concepts regarding zero trust architecture. We can see zero trust as simply a cybersecurity approach focused on data and capability protection. It is a very pragmatic perspective, ensuring trust is never assumed, is granted implicitly, and is continually verified. The goal is to ensure an organization can continue to function in a manner to support its mission or its reason to exist. In practice, as we'll learn in the next slide, means looking at nearly all organization assets in order to support the organization's continued operations. With that concept in mind, Zero Trust architecture is just an enterprise level implementation to support the principles and tenets of Zero Trust. The core tenets of Zero Trust architecture are: number one, all data sources and computing services are considered resources. Number two, all communication is secured regardless of network location. Number three, access to individual enterprise resources is granted on a per session basis. Number four, access to resources is determined by dynamic policy. Number five, the enterprise monitors and measures the integrity and security posture of all owned and associated resources. Number six, all resource authentication and authorization is dynamic and is strictly enforced before access is allowed. And number seven, the enterprise collects as much information as possible to improve its security posture. All these can actually be found in SP 800-207 as well. The key thing to think about is zero trust is what we're trying to do, and zero trust architecture is how we do it. How do we look at the organization and its assets in a manner that supports the concepts we just described? Many of you have likely seen a diagram like this one with a series of pillars supporting a structure. The number of pillars may differ, or you may see a slightly different layout, but in general, you'll see the same components shown here. Additionally, I've seen a diagram showing a series of interlockable puzzle pieces surrounding a piece labeled data. One of my favorites, I think it was done by the Gartner Group a couple of years ago, had the components as blocks connected by various integration lines. I really like that model because it did a great job of emphasizing that while the components are separated simply as a way to help focus our thought process, we cannot forget that none of them operate away from the other components, and their interaction must be remembered as well as planned for and designed in our solution. This diagram, created by the Government Services Administration, shows the organization's components and capabilities sorted into the categories of user, device, network, infrastructure, application, sometimes also known as workload, data, visibility and analytics, and orchestration and automation. Oftentimes we'll see governance as an overarching or surrounding component. For the sake of time, we will not dwell on the individual components and just focus on them as being a way to organize our thought process. Now that we have a basic understanding of some of the fundamental zero trust concepts, I'll discuss some of the challenges faced by a number of the early adopters that I've worked with. Hopefully, an awareness of these lessons learned may help you and your organization's migration planning. The first challenge is to recognize that ZTA is not a single architecture. It's not a design or map or a structure you can just place your operational components in and be done. Instead, it's a set of guiding principles and tenets. Because of this, it requires a greater degree of analysis on how the organization functions and how ZTA principles can best be implemented to manage its risks. ZTA may seem to be a drastic change from traditional boundary or perimeter-based security models of the past. In reality, you can think of ZTA as compartmentalizing the operation in a much more granular manner. It really is a practical evolution of the idea of defense in depth, which has been around for quite some time. As I stated above, ZTA planning and integration requires a level of operational understanding, which has been a stumbling block for many organizations. When they get to the point of segmenting network structure and implementing authorization within that segmented network, failing to understand the implications of those design factors will seriously impact functional capabilities. I think it's safe to say there are very few operations that will be in a state to support greenfield or clean environment builds. Instead, most organizations are going to be brownfield or actively operating environments which cannot stop functioning to perform this massive migration. Because there's no single tool or service provider able to fulfill all the requirements of ZTA, a great deal of integration planning will be required. This will necessitate a comprehensive, logical, and incremental test and implementation plan. With all that knowledge, why in the world would anybody with their organization through all this? If it's working, why fix it? At least in the US, one of the primary drivers for the federal government's migration is Executive Order 14028, which requires agencies to migrate to zero trust architecture in order to prevent negative impacts felt from an increasingly hostile threat landscape. This executive order is one of the main reasons why the United States seems to be at the forefront of formalizing ZTA implementation. While not yet passed, legal mandates are being discussed for organizations considered to be part of the nation's critical infrastructure. Additionally, there are data protection laws, such as Europe's General Data Protection Regulation, or GDPR, and California's Consumer Privacy Act, CCPA, that could logically become ZTA use cases. Finally, Executive Order 14028 also has sections addressing supply chain and federal contract acquisitions. So it would not be a stretch to see contracting regulations requiring ZTA certification, which would eventually evolve to general best practices. And while I mentioned the reasons for US pushing ZTA forward, I can tell you from both research and personal involvement, the global cybersecurity community is moving on ZTA guidance as well. I'm involved with IEEE's And the Cloud Security Alliance's efforts, and I know ENISA, or the European Union Agency for Cybersecurity, and Australia both have ZTA guidance efforts in progress. While the enterprise operation should have always been a consideration when developing IT infrastructure and capabilities, most of us know that the concept was largely ignored for more one-size-fits-all approaches. This will not work in zero trust architecture. The architecture must take operations and operational priorities into account. So how do we do this? John Kindervag is considered by many to be the founder of zero trust and zero trust architecture. He is said to have defined the concept in 2010 and is, without a doubt, one of the guiding lights of the movement. He has developed a zero trust architecture methodology that, at a high level, sets the foundation for any organization to create a successful ZTA migration plan. The first thing he did was define 4 design principles. Those are stated here. First thing we need to do is define our business objectives. What does your organization do? Write it out, because everything else we do should directly support those objectives or support capabilities that directly support those objectives. Number 2, design from the inside out. Think about your data and what you need to do with it. Design your security to address that, and those functional capabilities will roll up sufficiently secure and manage your operational risk. Designing top down from outside in is liable to enable missing key defense strategies or seriously overcomplicate the design model. Number 3, design least privilege access. You need to clearly document roles and responsibilities and design your privileges to support those tasks and nothing more. Watch out for unnecessary privilege creep that just always seems to work its way into designs. And 4, inspect all traffic. Any and all traffic should be inspected. It has value for metrics, as well as support infrastructure defense and incident response efforts. Think of where to best place your inspection points with this idea in mind. Kindervag also discusses a 5-step high-level methodology for designing a zero trust architecture for the enterprise. First and foremost, you need to define your protect surface. What do you need to protect? What sensitive data do you transmit, store, or process? It's critical to understand not only how your organization handles its data, but also the value of the data to your stakeholders. Most organizations consider data the equivalent of their crown jewels, and that data differentiates the organization from its competitors. What data types do you work with? Some data types, such as classified information, personal health information or PHI, person identity information or PII, and many other types have legislative safeguarding requirements. To match this concept to a mindset we can better imagine, I'll use questions I used to pose to clients early in my career when I was scoping backup and disaster recovery solutions. Some of the questions I would ask would be, what is your data worth? How long could you operate without it? How important is that it's accurate? And from your perspective, or the perspective of your customer and your operations, what would happen if your data was made public or at least got in the hands of your biggest competitor? Many of you may recognize questions related to confidentiality, integrity, and availability in those inquiries. That's not an accident. These questions or similar ones may help you to evaluate your data and support appropriate safeguarding decisions. Next, we need to understand what happens to that data. We need to map the data flows from the time it enters our boundary to the time it exits it. Now that we understand how the data flows, we design an infrastructure to support the best data flows and transaction activity possible. Look at potential logical and physical or virtual segmentation plans. This is going to require a fundamental understanding of how does the organization do what it does, and honestly, is that the best way to continue moving forward? This is time you may take to rethink how you do things. Once the network is designed, you need to create the automated rules to support the cybersecurity safeguards you have created. Fundamental concepts to think about are design flows and access controls to enforce least privilege and need to know. This is more than just ports and protocols. It's periodic user authentication and authorization. It's protecting the data through policy, decision, and enforcement points. This is ZTA at its functional core. Finally, you have to realize the work is never done. This is not a set it and forget it environment. You have to constantly monitor your environment to learn what is normal and what is anomalous. You have to make sure your design is performing as expected and evolve it as necessary. Check and make sure every iterative step is acting as intended. You don't know what you don't know, and monitoring will help you to learn along the way. So, what else do you need to consider to support this process? Well, how are you going to ensure organizational decisions are acted upon? How do your policies and procedures work together to support this unified vision? How often are you going to review and revise these factors to determine whether or not they're in line with your evolving mission or reason to be? What process will you put in place to propagate any changes? And then are you actually doing what you think you're doing? Are you acting on the feedback you're receiving? What mechanisms are in place to ensure you're acting on actual unaltered feedback? And this is where continuous monitoring and making a look at that feedback chain come into play. Finally, here's the real meat of what we're trying to get out today. What are some of the real obstacles you're likely to face? These are some of the expected challenges, as well as many that have actually been faced by some of the early adopters. Probably the greatest obstacle is going to be the change in mindset required for this exercise. This is such perceived change from the way things have been done in the past, and there's going to be strong pushback. Again, it's perceived mindset change. In actuality, it's just thinking more granularly about the way we've always done things. In some cases, legal mandates and regulations simply may not be enough of a driver. Presenting strong business cases for the migration are likely the best way to overcome this, but it will likely be slow. Migration, there's very few greenfield environments. This is going to require well-planned migration in order to minimize operational impact. Legacy equipment, working with a lot of government organizations, there's a lot of legacy equipment still out there, and some legacy equipment will not be able to address ETA requirements. You're going to need mitigation plans until the legacy assets can be replaced or just managed out of your operations. Both mobile application and remote workers present unique use cases that will require special considerations. Do not underestimate the challenges those two situations might present. Multi-factor authentication itself may be a challenge in many environments and use cases. Phishing-resistant multi-factor authentication may require even greater planning and use case examination. You have to make sure that your safeguards in place are in line with the categorization, how critical the data is, how critical are your operations. Realize I'm not going to put $100 procedure in place for a 10-cent component or something that is worth 10 cents to the operation. How do you balance security and privacy needs? You cannot just trample on privacy rights in the name of security. In some cases, there are legal privacy concerns that must be considered. Make sure you're looking at this from a government's perspective. Make sure you're looking at it as you're putting safeguards in place, that you're balancing the requirements of both privacy and security in a manner that you're mandated to. And finally, how do you assess your environment? What metrics do you look at during the course of your migration in order to get an accurate measure of your progress? How can you assess both compliance as well as quantitatively measure operational risk to support organizational decision making? Consideration must be given to how to assess this new architecture during the entirety of its life cycle. In the time we had today, we barely touched on the surface. This is a very complex area. For a more in-depth discussion, some of the details that we touched on here, you can look at CIS's guidance on monitoring, CSA's information to support microsegmentation and software-defined networks. How do you compartmentalize your network? And some of the joint government guidance on identity management and access control. It's much more rigorous than it's been in the past, and there's a whole lot of guidance information available to help support that. While by no means exhaustive, I've placed some core fundamental resources here, as well as the documents I've used as references for this presentation. Don't be afraid to look at some of these when you're trying to figure out the whys that you're doing some of these things, and also get a lot of guidance. This slide contains my contact information. Please do not hesitate to reach out to me with questions, or even if you just would like to share ideas. This is a relatively new and evolving area, and I think sharing lessons learned is critical to helping all of us achieve our overall goals of a safer cyber world and ultimately a safer terrestrial one. As we wrap up our time today, I'll repeat the request to submit your questions in the chat window. It's my understanding there will be a panel discussion later today, during which time I will be available to address them. Alternatively, just in case there are logistical issues with the Q&A session, as I stated in the previous slide, feel free to send me your questions, thoughts, or concerns. Send them directly to me and I'll be sure to get back to you. Thank you for your time today. It's been my pleasure to share just a little bit of the fundamentals of Zero Trust architecture with you all.